So in the previous class, we concluded the topic ellipse, parabola, and hyperbola, and some special case of hyperbola, that is rectangular hyperbola and degenerate conics. Okay. In this class, we know what is eccentricity. Okay. And in ellipse special case, that means our major axis, minor axis, and foci and vertex of ellipse focus. Okay, and some special definition of hyperbola, also ellipse. Okay, so start the topic. Okay, that is conic as a locus of a point. Okay, so conic is defined as the locus of a point moving in a plane in such a way that the ratio of its distance from the fixed point from a fixed point to the fixed straight line is always remain constant. So let us just correction. This is our ratio. Okay, so uh, then okay, so the fixed point is called focus. Okay, and the fixed straight line is called directrix. Okay, fixed straight line called directrix. And the ratio of this term, that means distance uh, of the point from focus to distance of the point from directrix, is called eccentricity. Okay, it is denoted by E. Okay, so the formula eccentricity is the distance of a point from focus distance of a point from focus to divided by distance of a point from directrix. Okay, so let us understand how eccentricity and how what is from focus, what is from distance, and what is from directrix. Okay, the next slide just see by the help of a diagram. Okay, Okay, just name the, this is our focus, that means limited f1, and this is another f2 focus, and the line is given by d dx, that means this line is called directories, and this point is c, and this point is given by v1, this is v2, and this is v3, and this is v1 dash. Okay, so eccentricity, okay, that formula is distance from a point from focus to the distance from point to directories. So if we select this curve, that means this curve, this is the point, that means the vertex point, this to this distance, and this to this distance. So v1 f1 divided by v1c, it's called eccentricity. Okay, the distance from a point from vertex, from focus, distance from this point to focus, and from this distance to directories, this line is called directories. Okay, and this distance is eccentricity is always a fixed. Okay, and this ratio is always fixed. So in case of ellipse, this eccentricity is less than 1. For ellipse, okay, and eccentricity is equal to 1 for parabola, and eccentricity is greater than 1 hyperbola. Okay, and very important, eccentricity is equal to 0 is for circle, and eccentricity is equal to root 2 for rectangular. Hyperbola. Okay, next we see how ellipse is formed. Okay, let's choose another point, this point to this point, and divided by this point to this point is eccentricity, which is always less than 1. That's for ellipse, this called ellipse. Okay, and this point to this point, sorry I changed the color. Okay, this point to this point to this point to this point, okay, it's always 1, that means this is our parabola, and this ratio is always fixed so that you can form the complete curve. Okay, next change the color. Okay, this point to this point divided by this point to this point, which is greater than 1, that means eccentricity is greater than 1 for hyperbola. Okay, clear. Eccentricity is now our next we see some special formula to determine the eccentricity of an ellipse. Okay, So write the heading: special formula to determine eccentricity of an ellipse. Okay, so we know the basic formula of eccentricity is uh, the distance from a point from focus to divided by distance from a point from directrix. This is the main formula, and by the help of this formula we can derive some special formula related to eccentricity of ellipse. Okay, so for this we just draw a ellipse. Okay, okay. So these are the directories. Okay, d dx. This is also directories. Okay, and let this point be m, and this point will be n, and these are the focus f1, and this is the focus from this type of curve, and this is the focus from this uh, concave type. Okay, as you know from mirror, this is concave, this is convex. So concave type, the focus will be formed by the intersection of this horizontal line with their curvature. Okay, so let's naming this name a, this point name will be b. Okay, so okay, we know eccentricity formula is af1 divided by am. Okay, also, and eccentricity will be this curvature bf2 for this curvature. Okay, I have to select this curvature. bf1 divided by bm. Okay, for this curvature we write eccentricity, and for this curvature, just a minute, we write no, bf1 divided by bm for the direction. Okay, next we can just subtract this. So E is equal to f1 minus bf1 divided by am minus bm. Okay, so in this case af1 minus bf1, which is equal to f1 f2. Okay, f1 f2 divided by am minus bm, am minus bm, which is ab. Okay, so how do you know af1? As you know, af1 is equal to bf2. Okay, so f1 is equal to bf2 So bf1 minus bf2, which is equal to f1 f2. Okay, and am minus bm, am minus bm, which is remaining this ab portion. So eccentricity always you can write the another formula from ellipse: distance between the foci, that means two focus, divided by AB. AB means length of the major axis. Length of the This is the length of major axis, and this to this point is minor axis. Okay, this is the another formula we have to remember. Eccentricity. Okay, so eccentricity, another formula for ellipse is distance between the two foci, that means two focus, and the divided by distance of the major axis, the length of the major axis. Okay, so another formula you can write. Next page. So we know a eccentricity is af1 divided by am, and also eccentricity is equal to bf1 divided by bm. You know, so eccentricity equal to af divided by am and bf1 divided by bm. Okay, so in this case we can just add this term, so we can get f1 plus bf1 divided by am plus bm. Okay, so af1 plus bf1, see, af1 plus bf1, we can get ab. This is af1 plus bf1, which is whole term ab, that means length of the major axis. So, ab and am plus bm, am plus bm, so am is equal to bm, so bm plus bn, which is mn. Okay, just see, given am plus bm. Okay, am plus bm, as you know, am is equal to bn, so bm plus bn, which is mn. Okay, am is equal to bn, so bn plus bm is equal to mn. Okay, so in this way we can write ab is length of major axis divided by distance between mn, means distance between directories. Okay, okay, this is formula, another formula. Okay, so from previous case we get eccentricity is equal to f1 f2, that means distance between two foci divided by length of the major axis, and in the previous slide we get eccentricity is equal to ab divided by mn. ab means length of the major axis and mn means distance between two directories. Okay, now multiply these two formula. Okay, so eccentricity square is equal to f1 f2 divided by mn, implies that eccentricity is equal to root over of f1 f2 divided by mn. Okay, so in what f1 f2 means distance between directories, sorry, distance between focus. Okay, this is distance between directories. Okay, this is another formula. Okay, this is formula 1, formula 2, and this is formula 3. Okay, this is special formula related to ellipse. Okay, next chapter, special definition of an ellipse. Okay, special definition of an ellipse. Okay, ellipse is a curve generated by a point moving in a plane in such a way that the sum of its distance from two fixed points is constant and equal to major axis, where two fixed point is focus. Okay, so ellipse is a curve generated by a point moving in a plane. Okay, in such a way that the sum of its distance from two fixed point is constant and where fixed point is called focus. See, this is our focus f1 and this is our focus f2. So this is the one chord which move that in such a way that the distance, the sum of this distance from two fixed point is always equal. Okay, so f1c plus cf2 which is equal to f1d plus ef2 constant. Okay, it is always constant, that's why it's form a ellipse. Okay, and this constant value as a given, sum of its distance from two fixed point is constant and equal to the length of the major axis, and its major axis is AB. So we know this point to this point, which is f1c, which is half of the AB. That means length of the major axis. The distance from one end of one minor axis, end of the minor axis of an ellipse is always equal to the half of the major axis. Okay, if it is the point is lies on the minor axis, is the condition. Okay, not always. If this C point is lies in the minor axis, so f1c will be half of the major axis. Okay, so write the definition. ellipse is a curve generated by a point moving in a plane in such a way that the sum of its distance from two fixed point is constant. Okay, and equal to this constant equal to length of the major axis, where the fixed where two fixed point is focus. Okay, this is the special definition of an ellipse. Next, we see special definition of hyperbola. Okay, so hyperbola is a curve traced by a point moving in a plane such that the difference of the distance from two fixed point is always constant. Okay, and this constant equal to distance between the vertices of the two branches of the hyperbola. Okay, let's see. So hyperbola. Okay, hyperbola is a curve traced by a point moving in a plane such that the difference of the distance between two fixed points. In the previous place, that means ellipse, the sum of the and the hyperbola in this case, the difference between 2 points. Okay, so see. This curve, the focus is f1. For this curve, this focus will be f2. Okay, okay. The distance between them is called, these are called transverse axis. Okay, so see this curve, one point is A, next point is B. Okay, so the distance between the two fixed point is always constant. Okay, so the difference of the distance between, that means f1b minus f2b is equal to, next another point A, f1a minus f2a, which is constant. Okay, and this value is equal to the distance between the transverse axis, this distance. Also you can write from this point, also C, f1c minus, sorry, f2c is greater than F1C. Okay. Another, this is D, F2D minus F1D. Okay. In this way, the difference between these 2 points will always be constant and the constant value will be transverse axis. Okay. So write the definition for hyperbola. Hyperbola is a curve traced by a point moving in a plane such that the difference of distance from two fixed point is always constant. Okay. In ellipse case, it is the sum of the distance of the two fixed point, and hyperbola case, the difference between the two fixed point, where the fixed point is called focus. Okay. So the distance from the two fixed point is always constant. And will be equal to the distance between the vertices of two branches. Hyperbola, that means the transverse axis. Okay. So you have to remember eccentricity is less than for ellipse, equal to 1 for parabola, and greater than 1 for hyperbola. Okay. These are the main important point. And some special case, that means eccentricity is 0 for circle and √2 for rectangular hyperbola. Okay. This complete the chapter conic section. Okay. Next chapter is our engineering curve. Okay. So our space divided into special curves. Is divided into two types, that is plane curve and another is space curve. Okay. So and in space curve it is type helix type. Okay, and it is further divided into cylindrical helix, and another is conic helix. Okay, next our plane curve is further divided into three types. One is cycloid, and second is involute, and next is spiral. Okay, so it is further divided into cycloidal. Okay, is cycloid is further divided into three types: cycloid, cycloid, epicycloid, hypocycloid. Okay, so it is belong to cycloidal family. Okay, next is involute family. Next is spiral family. So cycloid is further divided into three types. One is cycloid, two is epicycloid, three is hypocycloid. Similarly, involute is divided into involute of circle and second is involute of polygon. Next, spiral is further divided into Archimedean spiral and logarithmic spiral. Okay, so it is further divided into one is cycloid, okay, two is epicycloid, three is hypocycloid. Okay, next involute is further divided into two types. Next, four is involute of circle. Next, division four is involute of polygon. Next, spiral is divided into two types. One is Archimedean spiral. Next, second is logarithmic spiral. Okay, so cycloid is further divided into two. One is inferior trochoid. Next is superior trochoid. Similarly, epicyclic also divided into two types. One is inferior epitrochoid. Next is superior epitrochoid. Okay. Similarly, hypocycloid is divided into inferior hypotrochoid and second is superior hypotrochoid. Okay, these are the division of special type of core in engineering core. Okay. Next, we start the cycloid family. Individually, we can go cycloid, epicycloid, hypocycloid. Okay. So first is cycloid. Okay. So what is cycloid? So cycloid is a chord generated by a point on a circumference of a circle which rolls without slipping and jumping along a fixed straight line or a horizontal surface for a complete revolution of a circle is called cycloid. Okay. See, in a fixed straight line, okay. Let's take one point of a circle, this point. Next, for one complete next revolution, the point will move to this time. Next, from another second or another minute, the point will move to this point. Next, from another, the point will be moved into this. Next, another, the point will move to this. Actually, the point is moved from this point to this point, this point to this point, this point. As the point is not rotating from this fixed point, it is moving along the straight line, so it will trace another point. So now trace this point, we get this curve. It's called as cycloid. Okay, so write the definition. A curve generated by a point on the circle, on the circumference of the circle. Okay, a circle which rolls without slipping and jumping. Okay, with respect to this plane surface or line along a fixed line or a horizontal surface. for one complete revolution. Okay, circle. It's called cycloid. Okay. Next, cycloid is divided into two types, which is, you know, inferior trochoid and superior trochoid. Okay. As you know, cycloid is the curve generated by a point on the circumference of the circle which rolls without slipping and jumping along the fixed line or horizontal surface. Okay. In the case circumference, the point is traced by, it is called cycloid. And if the point is traced inside the circle, that means this may be, this may be, this may be, okay, inside the circle, not the circumference. Okay, it is called inferior trochoid. And if the point is traced by outside the circumference, uh, it is called superior trochoid. Okay. Let's see. If the curve is traced by this point, and after one roll it will move to this point, and after this it will move to this point, after this move from this point, and after this. So let's join the curve. This called inferior trochoid. Okay. Next, if the point is outside the circumference, so the point will be outside. Next will be outside. Next will be outside. Next will be outside, and here outside. So join the curve. This curve for superior trochoid. Okay. Let's complete the family of curve cycloid. Next, our curve is epicycloid and hypocycloid. Okay. So in the next class we complete what is epicycloid, hypocycloid, and the special type of curves. That means Archimedean spiral curve and logarithmic spiral curve. That's the complete our whole chapter of the our curve chapter. Okay. Next class we jump to the projection. Okay. So thank you.